On to problem 37 for your Algebra 1 Semester 1 final review. With problem 37, we have a bunch of inequalities here. And we know they're inequalities because of the shading. So inequality means we are going to shade. We also know they're inequalities because there's an inequality sign in between the left side and the right side of this equation, of this inequality. So let's take a look and just remember how we're actually supposed to graph that. So, few key pieces. Y is less than 3x plus 4. First, we graph what's called the boundary line. The boundary line is graphed just by treating the less than sign as an equals. And this is an equation in slope-intercept form. So I need to start up at 4, and I'll just put in all my tick marks for once. Okay. So we are starting at positive 4, which is up here. Then we're going up 3 to the right 1, or we could go down 1, 2, 3, left 1, down 1, 2, 3, left 1. And when we connect these dots, we need to remember that technically we're graphing strictly less than. So if y is always less than this side, we don't want the two sides to be equal. They're always equal at these points. These are the points that make the two sides equal. Because they can't be equal, we put a dashed or a dotted line, however you want to think about it. And if you want a reminder, you should probably label this that we have to dash this, right? If it said less than or equal, then we would make it a solid line, but it doesn't, so we don't. There's our boundary line. This boundary line separates all of the points that do work in the original equation from all of the points that don't work. So let's take a peek. We want to figure out if a point works or not. So let's say we try the point 0, 0. If I plug 0, 0 into my equation, I'll do this down here, that's a y of 0 and an x of 0. Doing a little math, the left side is 0, the right side is 0 plus 4, which is 4, and this says 0 is less than 4. That's true. That is good. This point worked. Now if we try to point on the other side of the boundary line, let's say we tried the point, oh, I don't know, 0, 1, 2, 3, 4, 5. Let's try 0, 5. Y is 5. X is 0. If we do the math, we get 5 is less than 4. That's not true. This point on the other side did not work. And with linear equations, that's always how boundary lines will work. This dotted line separates all the points that don't work. These ones up here don't work, with all the points that do. However, there's a pretty fast way to show someone who's reading your work which side has points that do work without just putting random smiley faces. And the way we do that is we shade in the points that do work. We do have to test a point, but as soon as we found that 0, 0 worked, we can go through and shade this side. It looks something like this. We leave the other side unshaded to show that none of those points work. Looking at this graph, we have a dashed line that takes away C. We know it starts at positive 4. That takes away A, and now we're down to B and D, which are the same graph, just they're shaded differently. B matches our shading.